Okay, basically the what design man. Okay. So basically, the difference between the D, good. Okay. Sorry. Uh, so basically, the difference between black between this partial D and the normal D is in partial D. For example, the f dx x y. It means that y is treated as constant. Well, in this case, usually f of x y of dx, in this case y usually as is a function of x. So so y is not constant but instead a function of x. So that's the main big difference between the partial and the normal one. Okay, is it is it clear now or okay? Good. Okay, so far so good, right? Any other question or can I continue? Okay, let's if there is no if there's question, please unmute yourself because maybe I cannot see you. Okay, so limit and continuity, basically it is the same as chapter 3. Chapter 2, but this is for multivariable one. The chapter 2 is only for, so the domain in chapter 2 the domain is only R, only one variable, where, where here the domain is usually on two two variable or two-dimensional, sorry, or three-dimensional. So that's the main difference, but basically the same. So if it's approach one by one. Next is about continuity. So basically, Basically, for the continuity part, uh, what we what we have here is uh, if it is continuous in x and it is continuous in y, it is continuous in xy. Is it what Professor Iman teach in the class? I want to ensure to you guys. Is it is it the same as in the class, or maybe Professor Iman teach differently? Hello? The same. Okay. Good. So because why I want to emphasize in this case, because in some mathematician thinks continuity in two-dimensional is something more complicated. So, for example, if uh, this is our normal uh, xy plane, and there is a sorry here it is x, y, and z. So it is a function. Z is a function of x and y. Here, for example, how to draw? Let's say I draw something like this. In this point, as you can see, it is continuous in both x and y direction. But if we approach from here, it's become discontinuous from the 45 degree. So um, some mathematician thinks that this function is not continuous in x and y. But because the book and the lecture use it is continuous in x and y, so we think that it is continuous in this case. Okay. Uh, is everybody clear? Oh, can you see my drawing like before? Okay, okay. If you cannot see, so uh, let's yeah. Jeka, can you use your mic so I can hear you?
What?
So okay. Let me try to draw. So if you cannot see, please tell me. So we have, for example, something like this. Okay,
I cannot see anything.
you cannot see
No.
anything.
Yeah, I just saw the lecture. Only the words on the
Oh,
original PowerPoint.
oh. Let me check. Let me check.
And now I can see.
You can see now.
Yeah,
Okay. So basically, what I want to to draw is something like good. Uh, okay. So you can see the black one, the black curve.
Yes. Yes.
So for example, this is the x direction, this is y direction. So it is, how to say, it is imagine this is dimension, okay? So this
Okay.
point, and this is basically, this is the plane, okay? The plane with some, not the plane, but function with some. So the one that I, this one is the function, sorry, the plane. So as you can see in this point, the function is continuous in x direction, right?
Yes. Mm,
It is also continuous in y direction, right?
right.
So what do you think? Do you think it is continuous?
Mm,
Hello? Do you
it's
think?
up to the definition.
Yeah, up to the definition, it is continuous. That's what I want to say, because for some other mathematician, it is not continuous, because if you see from this direction, it's not continuous.
Mm,
Okay,
I see.
you see. Okay, okay, thank you. You can mute yourself or not or unmute. It's up to you. Thank you very much. So now, the partial derivative. This is the definition. I think everybody understand this, so it's neither here nor there. Oh, by the way, can you try to do 31 and 34 here? Can you guys do it? Okay. Please tell me when you finish both question. Thank you. So basically, we try to solve the number 31 and 34. So please do it and tell me if you finish the problem. Thank you. Yes.
I want to ask about the squeeze theorem.
Yes.
Uh, is it need is it need to be like when we use the squeeze theorem? Is it need to be we have to, for example, like a uh smaller or equal than b and then smaller than equal than c, or it's just only need half part of it?
Both. You need both because that's the meaning of squeeze is from left and right, from both direction.
Okay, I see. Thank you.
You come. Okay. So I think for 31 is quite easy, right? Basically, we know that sine whatever is the value is between -1 and 1. So in this case, we can squeeze the xy sine 1 over x squared plus y squared by minus xy and xy because the value cannot be bigger than both. And as we know that in both case both go to 0 and 0, so one the answer of this problem is squeezed to 0. I think everybody agree about that, right? Slide 2 and slide 3. Okay, wait a minute. Slide 2 nothings, but slide 2 basically it's JK asked me what the difference between the partial derivative and the normal derivative. The main difference is in the partial. For example, here partial to the x, every other variable y, z, and anything must be treated as constant. Well, while in the full derivative, the d with the straight one, other variable, for example y, is usually a function of x or function, or maybe the x is function of y. Depends on the situation. But in the derivative one, for sure it is the other variable is constant. The second, the others is just the third slide is definition of limit. So basically, it's the same as chapter 2, but we do it in the multi-dimension. I think that's it. Is it okay? Okay, good. You come. Okay, are you guys ready for the number 34? Hmm. Okay, 32. Nice. Sorry. Okay. So let us try number 32. Basically, we have what? 0 smaller than square root of x squared plus y squared. So we need to find this delta so that um, xy over square root of squared plus y squared minus 0 is smaller than epsilon. Okay, good. So this one is xy over square root of x squared plus y squared. Must be smaller than epsilon. Okay. Um. Actually, this one is the same as what? As this thing is the same as square root of x squared y squared over x squared plus y squared must be smaller than epsilon. Okay. Mhm. Now, do you agree that sorry, do you agree that xy over square root x squared plus y squared is smaller than 1 over square root of x squared plus y squared? Do you agree with this statement? Can I see you? You can reply on the chat, or can we use Cauchy? Which Cauchy? Can you explain to me? Can you?
So I'm thinking of like x squared plus y squared will, like, basically when using Cauchy, like the x squared plus y squared will bigger than or equal to 2xy, right? And when we put them into the denominator, then our equation will be 1 over x squared plus y squared will less or equal than 1 over 2x squared, 2xy. And we take the uh
Positive and negative.
yeah, like take the absolute value, so that we have the epsilon. So like my epsilon will be the square root of x squared y squared over 2x squared y squared. Oh, wait, ye- I think I will join using my iPad and share my screen
Yes,
with
yes,
me.
please. Okay.
Sir, can I have the code? The code is IXUEWHJKTD, right?
Yes, yes, yes.
Okay. Is it presented?
I see your. Okay. Mm-hmm. Yes. Okay. Yeah, I can see you. Please continue. Mm, yes. Okay. Agree. Agree. Mm-mm. Ah, yeah. Hmm. Yes, yes, yes. I think yes, that's correct. So you can have the xy square root f xy over 2 in the one side and minus square root of minus square root xy on the other side. So you squeeze from both sides. Is it clear? Can you write that? So you squeeze from both sides. The left side is minus square root of xy over 2. The right side is yeah the one. Yep. Yep. That's correct. So I think that's the point that you understand the problem. So I think that's so. Dong, is it clear for you now about this thing? It is clear, right?
Yes, it's clear.
Okay, thank you. So maybe for the matter of time, I will continuing for some moment. Uh, so this is basically uh, the curve df dx df dy, the one that asked by Jake High before. So yeah, as I said before, it is. I think that's easy. Just fix the other y or z or whatever when you differentiate to the x and treat others as constant. That's all. So that's partial derivative. Maybe okay. Implicit theory. Did Professor Iman taught implicit theory before? Can I check? Did did you ever heard about implicit theory? Yes, no? Please answer if you can hear me. Hello?
I think is no.
No.
Yeah.
So it is well
Oh,
that's
is it implicit partial differentiation?
yeah, implicit partial differentiation.
Okay. Let me
Hit
check. Yeah, yeah, yeah. He talked that already.
already. So I think there is no question about that, right?
Yes.
It's so yeah, basically uh, df over df dx over df dy, and so that's neither here nor there. It's quite easy, I think. And the last part is until chapter 14.4, right? These tangent planes and linear approximation. Am I correct?
Yes.
Yes. Okay. Good. I think this one is basically the same as the tangent. Basically, tangent plane is the same as tangent line, but now it is plane. That's the difference. So we have before we only have one differential. Now we have two to the x and to the y. And linear approximation is linearization basically in the two 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 dimensional. If the domain is two dimensional. Okay, I think the time is up. Do you guys want to stop here or want to want to do this problem, or do you have any question? What do you think? Hello? What do you
This one is the linear approximation, right?
Yes, linear approximation, just linear approximation. I think um maybe I do the last part this one.
Okay.
So the z dzdx is what 1 over x minus 2y, and dz dy is equals to minus 2 over x minus 2y. So as we see, the linear approximation become uh, what? So f 0, sorry, f 3.1 is basically what? 0, right? Yeah, this is, sorry, this is 0. So L is 0 plus 1 over uh, 1 minus, sorry, 3 minus 2 over what? X minus 3 plus a minus 2 over 3 minus 2 over y minus 1. So this one L x y is x minus 3 minus 2y plus 2. So x minus 2y minus 1. I think yes. So this it's easy, but yeah. Is is there any question? Is it no? Okay. Is it okay if uh we finish now? Okay. If no more question, I think that's it for today. Thank you for coming to the our online tutorial. See you next week. Okay. Welcome. Thank you. Bye.